This lesson is on a new kind of trigonometric proof that has factorable expressions in it. We'll be using the Pythagorean trigonometric identities as well as the other identities that we've talked about earlier. So the first example is the following. If I'm asked to show that the sine of x minus sine of x times cosine squared of x is equal to the sine cubed of x. So our first rule has generally been make everything, make all the substitutions that turn everything into sines and cosines. But we already have that here. But if you look at the left-hand side, we do have a sine of x common to both terms. So I can factor out the sine of x, and I'm left with 1 minus cosine squared of x. Now I have the sine of x times the quantity 1 minus cosine squared. And we need to go to our trigonometric identity that sine squared of x, our Pythagorean trigonometric identity, that sine squared of x plus cosine squared of x equals 1. And if we look in the parentheses here, 1 minus cosine squared, I can rearrange the sine squared plus cosine squared equals 1 into sine squared of x equals 1 minus cosine squared of x if I subtract cosine squared from both sides, which now gives me exactly what's in the parentheses. And so now I can substitute sine squared for the set of parentheses. So I have sine of x times sine squared of x equals sine cubed of x. And of course, sine squared times sine is sine cubed. So that completes our trig proof. The next example is a little more complicated. We have secant to the fourth of x minus tangent to the fourth of x over secant squared of x minus tangent squared of x, I'm sorry, plus tangent squared of x equals, we have another term in there, plus tangent squared of x equals secant squared. So this looks fairly complicated. And if you notice in the numerator of the first term here, this fraction, this numerator is the difference of two squares. It's the difference of secant squared squared and tangent squared squared. So I can factor that numerator into the secant squared of x plus the tangent squared of x times secant squared of x minus tangent squared of x. I'm going to leave the denominator alone. And I'm going to leave the tangent squared alone. See how I can algebraically simplify that first fraction. If you look at the numerator and denominator, we have the same thing in the numerator and denominator. We have a product in the numerator. So that means we can reduce that first fraction by canceling common factors. So the numerator becomes secant squared minus tangent squared, and the denominator becomes 1. So I can now just write that whole first fraction as secant squared minus tangent squared still my term tangent squared here. And now I can simplify. I have secant squared minus tangent squared plus tangent squared, and that's simply secant squared on the left-hand side, and that was what we were shooting for. So that completes that trig proof. Now, as I say quite frequently, there are times that we can do things, but should we do them? So let's say I have the following problem. I have cosecant squared of x minus 1 divided by tangent of x, and I want to show that that's equal to cotangent cubed of x. Well, if we look at the numerator, that is the difference of two squares. It's cosecant squared minus 1 squared, which means I could rewrite the numerator as cosecant of x minus 1 times cosecant of x plus 1 tangent x. And we're trying to see that that's cotangent cubed. Well, I think if we try to do this, we're going to end up having to expand that back out anyways, because it's going to be tough for us to get to cotangent of x this way. So I can't really see a clear path to get to cotangent cubed by substituting or simplifying. So I'm going to go a different route. And I'm going to say, well, this was nice, this factoring idea, but I don't think that's going to help us. And then I look at that numerator again, and I have to think. I remember seeing a trigonometric identity with cosecant squared in it. So what was that trigonometric identity with cosecant squared? It was well, if you can't remember it, we can develop it, right? We remember sine squared plus cosine squared equals 1. And I want to get cosecant squared. That means I need sine in the denominator. So I get 1 plus cotangent squared equals cosecant squared. So at this point, I can either just substitute 1 plus cotangent squared into the numerator, or I can recognize that, well, I want cosecant squared minus 1, so if I subtract 1 from both sides here, I get exactly that. So now I have exactly what my numerator is, and I have a substitution for it now, cotangent squared. So I can now rewrite the first the fraction as cotangent squared divided by tangent, and I'm trying to show that that's equal to cotangent cubed. So cotangent squared divided by tangent, well, tangent is 1 divided by cotangent. Okay, so I can make that substitution. And then I have cotangent squared divided by a fraction, which is the same as cotangent squared times the reciprocal of that denominator fraction. And the left-hand side now is cotangent cubed. So if you see the difference of squares or some factorable form in one of these trig identities, you want to maybe give it a try, but You want to also be cognizant of the fact that you may have a substitution already at hand by using the Pythagorean trigonometric identities or the reciprocal identities that we've talked about in the past. And that concludes this lesson.